So let's talk about responsiveness, right? When, from your point of view as a user, you click some button in a web app and eventually something appears that is the result of whatever you did, right? Some indication that the site responded to what you did. So where does that performance go? Like, where does the time go? Well, from the time that you make the request hits the server, which is somewhere in the cloud. It spends a little bit of time in the operating system and the network stack. The web server has to get a hold of the request. It has to pass that along to the app server, wherever that might be. So this is the point where like your code actually gets control. Your controller runs, maybe it does something with the model. Maybe the model does something to the database. So some time is going to be spent by the database doing its thing and getting a response to you. Then the view has to be rendered, right? The HTML or whatever has to be prepared to be sent back to the user. And that has to go back out through the network stack. And once all of those things has happened, the first byte, conceptually, is getting delivered back to the user's browser. But you can't really do anything with the first byte, right? There's a certain minimal amount of the page that you need to have before you can draw anything. So the total amount until everything is done is the overall response time. But some people use the term time to glass. That's back when most people's screens were actually glass because they were monitors as opposed to the flat, the LCD plastic panels we have today. At that point, and this depends a lot on the engineering of the web browser, the browser's job is like, how quickly can I draw something? And I'm sure you've all had the annoying, the page appears and you start moving the mouse to click on something. And as you're moving the mouse, the page shifts the layout all over the place because the browser is trying very eagerly to show you something, anything, as soon as possible to make things feel fast. But the cost of doing that is as more data arrives, like the images that are being fetched, JavaScript that is creating new boxes on the page, until all of that stuff is sort of settled down, the layout might not be stable, right? So there's this trade-off of how soon do you want to start drawing stuff versus drawing stuff and not having it change. So when all of that rendering is done and the page is sort of stable and ready to be interacted with, that's usually how response time is defined. It's the last byte of the page has been delivered. So as you can imagine, not all parts of this are parts that you can control. So which parts do you control? Well, certainly the app, right? Your code in the controller, your code in the model, you get to control those. You can optimize that code. What about the database? Well, the engineering of the actual database is probably not something you control, but you can certainly control how the database is set up. You can control what queries you're sending to it. You can use indices, which we're going to talk about shortly. So you don't control the database, but you control how you use the database, and we'll have a lot to say about that. The view rendering. You have a lot of control over views because you author them. You're providing the template that gets filled in, and you're providing CSS that will determine how it ends up looking. So, for example, we've seen versions of this before where attaching IDs and classes to elements not only is useful for CSS styling, but it actually makes the browser traverse the DOM a lot faster. Right. So, for example, if I want to make sure that a certain element of my page has a certain appearance, one thing I can do is attach a CSS class or ID to it. That lets the browser find it really quickly. And so when the browser is sort of going through the CSS and matching up with which style am I supposed to apply to which things on the page, you want to make the browser's job easy in terms of finding things on the page. So what would be an example of making it not easy? You can write a CSS rule that says, if I have something that's an element with this ID and it's of this type, and then inside of it, there's a table, and I want the third row of the table, which has a div embedded in it and has some span, and then I want the span to be red, right? The amount of time it takes the browser to traverse all of that and figure out the rules, that contributes to overall page rendering time. So there are things you can do, just like you can avoid abusing the database, you can avoid abusing the web browser. You can be nice to it. As another thing we'll talk about is when you're rendering a view, remember that that's computation, right? You're running Ruby code that will replace some parts of an HTML template with the result of running some functions. So it's not just the running of the function, like that assembly process takes time. And that has to happen entirely before that can be shipped back to the client. So one thing that might occur to you is if there's a page that's sort of expensive to put together, can we cache parts of that page so that in the future, we don't have to recompute it until something about the page would change? So we'll talk about how to do that as well. Then there's things like embedded assets. If you have images that are embedded in your page or big blobs of JavaScript, there's no reason for those files to go through the Rails stack. In fact, there's no reason for them to be served from your site at all. You can have them served from a third-party asset server, like Amazon is very inexpensive for this, And you can have a cache in your deployment. We'll show a diagram of how this works, where the embedded assets they're basically become not your problem. They can be served in parallel from a fast server that is optimized for serving big blobs, and they can be cached locally so that the user probably only has to load them once. And when they do reload them, they'll be cached right on your Heroku deploy. Similarly with JavaScript, if you're loading a big JavaScript library like Bootstrap or jQuery, Google and other companies maintain servers that are just optimized for serving those. They serve a recent version really fast. They have generous cache expiration times so that, again, if the user's browser has loaded it, they probably don't need to load it again for a long time. So the thing that all of these have in common, though, is that before you decide which of these you're going to do, you have to take some measurements. You have to know where the problem is before you aim for fixing it. And so we'll show some examples of tools that can help you do that.